The economic return on this technology is very large, but even more importantly, the way in which we are moving to a new economy, right? An AI integrated economy, an AI powered economy. And this is ultimately what our mission is about, right? It's like we see this change on the horizon. We want to help. We want to help steer it to be something that uplifts everyone, right? That it's this amazing opportunity, almost unique in human history. And
Greg Brockman just confirmed that the road to AGI isn't about building one single monolithic god in a box. He laid out a vision from inside OpenAI that is far more nuanced and, frankly, far more achievable. We're going to break down the key moments from his latest conversation that reveal OpenAI's real strategy. Let's start with the most fundamental architectural shift he discussed, the idea that the future of AI is not a single model, but a manager of models.
The flip side, though, is that I think that the evidence has been away from having the final form factor, the AGI itself, being a single model, but instead thinking about this menagerie of models that have different strengths and weaknesses. And I think that's like a very interesting finding of the past couple of years, right? Just a direction of like, it's much easier to have a small, fast model that's less capable, but can just do a lot more. You can generate a lot more tokens from it, coupled with a much more expensive reasoning model. And if you combine those two things, you kind of get adaptive compute. And that we haven't really cracked how do you do adaptive compute within the architecture, but doing it within the orchestration of a system, it's very straightforward. And so I think you get a lot of power out of the fact that these models are composable in this way.
This is a monumental statement. The pursuit of AGI is no longer a quest for a single unified consciousness. It's an orchestration problem. What Brockman is describing is an AGI built like a company, with a manager directing a team of specialized agents. Some are fast and cheap for routine tasks, others are slow, expensive, deep thinkers for breakthrough work. GPT-5's hybrid model is the first commercial version of this. The implication is that we're building ecosystems of intelligence, not just algorithms. I think this makes the path to AGI more resilient and economically viable. We're going to stop asking how big is the model and start asking how effective is the system. So if the system relies on a powerful reasoning model for the hardest tasks, just how powerful is the top-tier model inside GPT-5? Brockman's description is chilling.
Yeah, I think it's smart. I think that the intelligence of these models is starting to be just almost undescribable. Right? It's like there's still limitations. There's still ways in which they fail. But it really is the case that for extremely hard domains, like look at the IMO results, right? So you can take a model that's been trained on this reasoning paradigm and it's able to write proofs that is at the level of the best humans, right? And it's like in this specific domain, there's limitations, et cetera, et cetera. We haven't proven like an unproven theorem, any of that stuff, but it's real. It's like, it's undeniable at this point that these models are able to perform great intellectual feats. And I think that's new, right? GPT-4, I think, was like much more, it was kind of capable and commercially useful across a wide range of applications, but the ideas that it produced were not very deep, right? The problems it would solve, it was not very reliable at.
He contrasts it with GPT-4, which he admits produced ideas that were not very deep. This isn't an incremental update. This is a phase shift from a tool that retrieves and remixes information to a genuine intellectual partner. He later mentioned a physicist who said GPT-5 re-derived an insight that took him months of research. The implication here is the radical compression of discovery. What used to take a career could take a year. What took a year could take a week. This is the beginning of the end for the lone genius working in isolation. The new paradigm is a human-AI partnership, pushing the absolute frontier of science and knowledge. But what is the one resource, the one fundamental fuel that makes this incredible leap in intelligence possible?
Well, the bottleneck is always compute.
Right.
And I mean that in a real way, right? It's just like, it's very clear that if you give us a lot of compute, that we will find ways to iterate that actually make the most of that compute. We are in a world where right now, we now have much more sample efficient algorithms, right? With the RL paradigm, but it does take a lot of compute still, right? It's like that you have like one task a human created or 10 tasks or 100 tasks or some small number of those. And then you have a model that tries a bunch of times, not just one time, not just 10 times, but 10,000 times to try to accomplish one task. And you select from those and you learn from that. And again, it's like the amount of leverage you get as a human designer there is extremely high, but the amount of compute that you have to pour in order to make it work grows proportionally.
The bottleneck is always compute. This is the brutal, simple truth of the AI race. It's a statement of absolute conviction. The progress we're seeing isn't primarily from some magical new algorithm that nobody else has. It's from the industrial-scale application of reinforcement learning powered by unfathomable amounts of compute. The real game changer isn't just a better idea. It's the infrastructure and the will to scale it 10,000 times on a single problem. This philosophy redefines the frontier of AI. It's not just a software problem anymore. It's a hardware, energy, and supply chain problem. The entire geopolitical landscape, the battles over chips and data centers, it all stems from this one core principle. This principle becomes even more staggering when you realize the language these models can learn isn't limited to humans.
Well, the thing I found most remarkable about working on DNA neural nets is that they're exactly the same.
Yeah.
Right? It's just you replace human language.
It's even like a simpler vocab.
It is.
Yeah.
Yeah. You've got four letters. That's all you got.
But don't you tokenize at a higher level?
Yeah, I mean, so you can. But actually, the way that we approached it was we just did
Character level?
Character level.
No way.
Yeah. Why not?
Well, it's, I guess there's no reason. I don't know. There's only 4.
Right. And this to me is, I think, the core, like one of the interesting things about human language is we understand the semantics, right? We kind of understand what it means, what the structure is. It's very easy for us to observe. We kind of have a sense of, when you look at a tokenization scheme, you have a sense of, did you capture like all of the words in a reasonable way and all this stuff. Biology, it's an alien language.
This is one of the most profound statements I've ever heard from a leader in this field. DNA neural nets are exactly the same. He's confirming that the transformer architecture is not a language model. It is a universal pattern recognition engine. It can learn the grammar of an alien language, biology, just as easily as it learns English. The implication is almost too vast to grasp. We are on the verge of applying the full power of this technology to the source code of life itself. My take is that we have to stop thinking about medicine or material science as separate fields. We are about to enter an era where biology becomes a programmable system, and the timeline for that just got radically shorter. So, as these universal learning machines become more capable, how does it change the day-to-day work of the very engineers who are building this future?
So I think we're still at the early edge of this, but the thing I've seen be most successful is that you really build code bases around the strengths and weaknesses of these models. And so what that means is more self-contained units have very good unit tests that run super quickly and that have good documentation that explains what this module is for. And if you do that and you kind of leave the details to the model, it works really well. And then thinking about how these things compose and making sure that you're thinking about the dependencies, that you only have these like clean, like AI optimized modules can only be depended on by other AI optimized modules, then you end up with like a whole system that's actually AI optimized. And so I think that we're still scratching the surface of what's possible.
Brockman is giving us a direct look into the blueprint for the future of software development. The new paradigm is architecting for AI. It's not about the model writing an entire application from a one-sentence prompt. It's about human engineers becoming true architects who design clean, well-documented, and independently testable modules. You define the what and the why, and the AI handles the how, the implementation details. The most valuable engineering skill of the next decade won't be writing flawless code in a specific language. It will be systems thinking and the ability to design these clean, AI-friendly abstractions. Your job shifts from being a bricklayer to being the architect of the entire cathedral. And the scale of that cathedral is something that's hard for most of us to even comprehend.
The engineering project that we collectively, as a country, as a society, as a world, are undergoing right now, right? It's like projects like the New Deal, like pale in comparison. You know, the Apollo program, pale in comparison to what we're doing right now. And in many ways, it's as it should be, right? Like that the economic return on this technology is very large, but even more importantly, the way in which we are moving to a new economy, right? An AI integrated economy, an AI powered economy. And this is ultimately what our mission is about, right? It's like we see this change on the horizon. We want to help. We want to help steer it to be something that uplifts everyone, right? That is this amazing opportunity, almost unique in human history. And
this is the context for everything we've just heard. When Brockman says that projects like the Apollo program pale in comparison to what's happening now, he's not exaggerating. We are witnessing the largest and most rapid technological mobilization in human history. This is not just about building a better search engine or a coding assistant. It's about constructing an entirely new substrate for the global economy, an AI-powered layer for civilization. The shift we are living through right now is more akin to the invention of agriculture or the Industrial Revolution than the invention of the Internet. It's a fundamental change in how we create, discover, and organize ourselves. My final prediction is this. The next 5 years will make the last 50 years of technological progress look like a practice run. We are at the base of an exponential curve unlike any we have ever seen. What do you believe will be the first industry to become completely unrecognizable because of this shift? Let me know your thoughts below, and if you want more analysis like this, make sure to like and subscribe.